Chapter 6 is all about similarity, and this can be really useful in terms of figuring out how tall a tree is without actually climbing up the tree, or figuring out how big a TV is going to be if you're told that it's in the 16:9 ratio. So we start with the concept of a ratio, and the ratio of A to B is A divided by B, a quotient or a fraction, and it can also be written as A dot dot B, which is just the ratio of A to B. Now, I mentioned the TV ratios, and you'll notice that whenever you go out to buy a new TV sometime, you'll be given that the TV has some kind of ratio to it. And the reason that we use this is in cinema, when they record a film, they decide to have some kind of aspect ratio which would fit any size screen. So if you ever notice that you have, let's say, a 21 to 9 ratio TV, 21 to 9 aspect ratio, and you've got two black bars on the side, that's because it was recorded in a smaller ratio, so it has to cut off the sides here to make it fit your TV. If two ratios are equal, then we can write a proportion, which is just an equation that relates the two ratios. So the ratio of A divided by B is equal to the ratio of C divided by D. Basically what this means is that one fraction is going to be a multiple of the other one. And a little bit of vocab, we call A and D, the numerator of the first ratio and the denominator of the second, we call those the extremes. And C and B, as indicated in the red, those are called the means of the proportion. One thing we can do in solving a proportion is use something called the cross product property, which is basically just take the cross product. So if we have that B and D are not 0, because dividing by 0 would be not allowed, it's impossible, undefined, what we can do is go ahead and multiply across. A times D is equal to B times C. And basically where that comes from is just a little trick. It's just a quick way to multiply. If we wanted to simplify these fractions, we can multiply C divided by D times D, so you'd multiply this side by D and this side by D, and D over D would equal 1. So we'd be left with C is equal to AD over B, and again, multiplying both sides by B, we'd be left with our answer down here. Let me show you a few examples of solving a proportion using cross products. This first one I'm just going to solve the old way. So I see a 7 in the denominator of the first fraction, so what I'm going to do is I'm going to multiply both sides by 7. By doing this, 7 over 7 is 1. I'm left with x is equal to 3 times 7 is 21, still divided by 2. My next step, I want to multiply both sides by 2. 2 over 2 is 1, and I get that 2x is equal to 21. Lastly, divide both sides by 2, and I get that x is equal to 21 halves, which is the same as 10.5. Notice I did this the old-fashioned way. Let's do the simple trick on the next one. So I'm just going to take the cross product, which a way of showing that is by circling these two sides. So I'm going to multiply 4 times 4x plus 3 and set it equal to, make sure you carry that equal sign, 5 times 12. So you're multiplying across the diagonals, the cross product. Now 4x plus 3 I have to distribute to each term. So 4 needs to go to each of those. 4 times 4x is 16x. 4 times 3 is 12. And that's equal to 5 times 12, which is 60. Now a little bit of simplification. Subtract 12 from both sides. I'm trying to isolate the x variable. And I get 16x is equal to 48. 60 minus 12 is 48. Lastly, the coefficient in front of the x, the 16, needs to be divided out, and I get that x is equal to 3. Go ahead and try number 3 on your own, and make sure to check your answer by plugging it back into the original proportion. To find the geometric mean of two numbers, so you start with two numbers, a and b, and they can be any positive number, but note that they must be positive. And what you're looking for here is some number x that satisfies this proportion equation. So when you go to solve this for x, you take the cross product. AB is equal to x times x is x squared. And then solving for x, square root both sides, and you get that x is equal to the square root of AB. So when given, as in number 4, find the geometric mean of 2 and 50, all you have to do is say, well, the geometric mean is x is equal to the square root of the product of the two. 2 times 50. This is the square root of 100, which is equal to 10. So now what this means is that if you take one of the numbers, 2 in this case, divide it by the geometric mean, that should equal the geometric mean divided by the second number. 2/10 is the same as 1/5, and that in fact does equal 10 divided by 50, which is also 1/5. So we found a number, 10, that divides the first number and can be divided by the second number. It's our geometric mean. Go ahead and try number 5 yourself in your notes. And just a little heads up, it's okay to get a decimal in this case. Notice that the square root of 100 this time was a nice pretty 10. When you work out number 5, you might not end up with that. Now that we know what a proportion is, let's put it to work. So here we have a figure, and we have another figure with inside of it. So these would be looked at as two triangles. We got a triangle JKL and JGH. Now in this diagram, we're told that this proportion holds true. And we're actually given some values. So we're asked to find JL and JH. Those are unknowns. We'll start with the proportion given. JL, we do not know, divided by LH is given to us, it's 2, is equal to, JK is given as 15, and KG is given as 5. So now we just have to solve this proportion taking a cross product. 5 times JL is equal to 2 times 15. So 5 times JL, notice how I'm using parentheses here. JL is just some variable. I could have called it X, I could have called it something else, it doesn't matter. And that's equal to 30. We're solving for JL, so we want to get rid of that coefficient by dividing it out. 30 divided by 5 is equal to 6. So JL is 6. Found one of them. Now we have to find JH. And JH is JL. It's equal to JL plus LH. So we found JL was 6. LH is labeled as 2. 6 plus 2 is equal to 8. And we are done. You may have heard the term pixel before in terms of camera resolution or pixels on your iPhone screen. And in this question we're going to look at pixels on a TV screen. So you're going to buy an HD TV and you estimate, or the manufacturer estimates, that there's 2,000 pixels for every 7 square inches on a TV. But you're going to buy a TV that has 74 square inches on the screen. Not a very large TV, but a TV nonetheless. So this is just a proportion that we can set up. We can set up the ratios and create an equation with it. So what we have is 2,000 pixels for every 7 square inches, and we want to know how many pixels are in 74. So the proportion is set up as such. Now taking the cross product, 74 times 2,000 is equal to 7 times x. 74 times 2,000 is 148,000 equal to 7x. And finally, solving for x, divide both sides by 7. X is equal to the number of pixels that we were looking for, which is approximately 21,143 pixels. As a heads up for when you're approaching problems on your own, it would not be incorrect if I had set this up in reverse. If I had said for every 7 square inches we have 2,000 pixels, and for every 74 square inches we have X amount of pixels. It still will give you the same answer. It's the same proportion, same ratio setup, just set up in the reverse manner. So there's not one perfect way to solve these problems.